Right now, light is racing past you at 670 million miles per hour. Nothing in the universe can catch it. Not rockets, not particles, not even the fabric of space itself can push matter beyond this cosmic barrier. For centuries, scientists assumed this was just a property of light, a speed to be measured, cataloged, and eventually surpassed. They were wrong. The speed of light is not a speed limit for light. It is the speed limit of causality itself. It is how fast reality can update. It is the maximum rate at which the universe can communicate with itself. Every atom in your body obeys this law. Every thought in your brain is constrained by it. Breaking this limit would not merely require faster engines. It would require unraveling the logical structure of existence. To understand why this barrier is terrifyingly absolute, we must first trace the history of our collision with it. The journey begins in the flickering candlelight of 1638. Galileo Galilei climbed a hillside outside Florence, carrying a lantern and an impossible ambition. He wanted to measure the speed of light. His assistant waited on a distant hill with an identical lantern, instructions memorized, timing rehearsed. The experiment seemed elegant in its simplicity. Galileo would uncover his lantern. The moment his assistant spotted the flash across the valley, he would uncover his own. Galileo would measure the delay. The logic was flawless. The execution was perfect. The result was nothing. No matter how far apart Galileo positioned the lanterns, the returning flash appeared instantaneous. Then he concluded that light was either infinitely fast or moved so quickly that human perception could never detect its finite speed. The problem was not Galileo's method. The problem was scale. Light circles our entire planet 7 times in a single heartbeat. Galileo was trying to measure a 5 microsecond delay using biological instruments that lagged by 1/4 of a second. The signal drowned in the noise of human biology. Measuring light speed required a laboratory vastly larger than the Earth. It required the solar system. In 1676, the Danish astronomer Ole Rømer arrived at the Paris Observatory to track the moons of Jupiter. He noticed a disturbing pattern in the celestial clockwork. The eclipses of the moon Io drifted throughout the year. When Earth orbited closer to Jupiter, the eclipses occurred earlier than predicted. When Earth swung to the far side of the sun, the eclipses arrived late. The discrepancy accumulated to roughly 22 minutes. Rømer realized the eclipses were not drifting. The news of the event was simply taking longer to cross the void. He had proven that light was not instantaneous. It was a physical traveler, subject to the tyranny of distance. By the late 19th century, physicists had established light speed at approximately 299,792 kilometers per second. But this precision birthed a crisis. If light was a wave, as experiments suggested, it must wave through something. Ocean waves require water. Sound waves require air. Victorian scientists hypothesized the luminiferous ether, an invisible substance filling the vacuum of space. If this ether existed, Earth's motion through it should create an ether wind, altering the measured speed of light depending on the direction of our orbit. In 1887, Albert Michelson and Edward Morley built the most sensitive optical instrument in history to detect this wind. They floated their apparatus on a pool of mercury to dampen vibrations, splitting light beams to race against each other. The result was the most famous failure in the history of science. They found absolutely nothing. The speed of light was identical in all directions. The ether did not exist. The void was truly empty. This null result threw theoretical physics into chaos until a patent clerk in Bern, Switzerland, picked up the pieces. Albert Einstein didn't try to fix the ether theory. He discarded it. In 1905, he proposed that the speed of light is a universal constant, an invariant for all observers regardless of their motion. This sounds simple, but the implications are horrific for our intuitive understanding of reality. If you run toward a beam of light, it does not hit you faster. If you run away, it does not hit you slower. It always approaches at exactly 670 million miles per hour. For this to be true, speed, which is distance divided by time, must remain constant, meaning distance and time themselves must change. This brings us to the relativistic nightmare. Einstein revealed that space and time are not rigid stages upon which the universe acts. They are flexible, dynamic, and inextricably linked as space-time. To keep the speed of light constant, the universe distorts reality for the observer. This distortion manifests as time dilation and length contraction. As you accelerate, time slows down for you relative to the outside world, and space compresses in the direction of your motion. Imagine you are strapped into a spacecraft with an engine capable of infinite thrust. You ignite the drive. Acceleration slams you back into your seat. 10% of light speed, 20%, 50%. Everything seems normal inside the ship, but outside, the universe is reacting to your insolence. As you pass 90% of light speed, something mathematical and monstrous begins to happen. You are no longer fighting air resistance or friction. You are fighting the geometry of space-time itself. The energy required to increase your speed is governed by the Lorentz factor, or gamma. At rest, gamma is 1. At 90% of light speed, gamma is roughly 2.3. You are effectively twice as hard to push, but as you climb to 99%, gamma spikes to 7. Every inch of acceleration now costs 7 times the energy it did at the start. Push harder. 99.9%. Gamma is 22. You are pouring fuel into the engines, but the speedometer barely creeps upward. The energy that should be making you faster is instead being converted into relativistic momentum. You are becoming heavy with energy. The universe is conspiring to prevent you from reaching the limit. At 99.9999%, you are not approaching a barrier you can break through. You are approaching a mathematical asymptote. To reach 100%, to match the speed of a photon, gamma becomes infinite. You would require infinite energy. More energy than exists in every star, galaxy, and black hole in the observable universe combined. This is not a technological limitation. It is not a matter of building a better engine. It is a fundamental prohibition written into the source code of reality. Massive particles, like the protons in your body or the hull of a ship, simply cannot exist at light speed. The Large Hadron Collider proves this every day. It accelerates protons to 99.9999991% of the speed of light. At this velocity, a single microscopic proton carries the kinetic energy of a flying mosquito. The proton is billions of times lighter than the insect, yet their energies match because the proton's relativistic mass has exploded toward infinity. To bridge that final fraction of a percent, to push that proton to light speed, would require consuming the entire universe as fuel. But the barrier is not just about energy, it is about time. As your velocity increases, your flow of time restricts. At 99.9% of light speed, a voyage that takes a century for Earth takes only a few years for you. If you could reach light speed, time would stop completely. For a photon, the moment of its creation in a distant star and the moment it hits your retina billions of years later are the same moment. A photon experiences no time, no distance, no duration. It exists in an eternal, frozen now. For massive objects, this state is forbidden. We are creatures of time, and therefore, we are exiled from the speed of light. Einstein showed us that this barrier exists and demonstrated its mathematical impenetrability. His equations describe precisely what happens as objects approach light speed. They reveal the asymptotic impossibility of reaching it. But he did not reveal why the universe demands this enforcement. That understanding would require decades more work. and new mathematical frameworks, and a physicist named Richard Feynman who could visualize quantum reality in ways no one else had imagined. The answer lies in the quantum mechanical structure of reality itself. Einstein showed us that the speed of light is a cosmic wall, fortified by infinite energy and frozen time. But he did not explain why the wall exists. Why is the universe structured to prevent hypervelocity? Why is the limit exactly 299,792 kilometers per second and not infinite? To answer this, we must leave the smooth curves of relativity and descend into the chaotic, probabilistic bedrock of reality. We need a different kind of mind, one capable of visualizing the impossible. We need Richard Feynman. In the autumn of 1939, a 21-year-old Feynman arrived at Princeton University carrying a reputation for irreverence. While other physicists memorized formulas, Feynman reinvented them. He didn't trust equations he couldn't visualize. He saw the universe not as a static stage, but as a dynamic dance of particles. This visual intuition would eventually crack open the deepest secret of the speed of light. The problem Feynman inherited was that quantum electrodynamics, the theory of how light and matter interact, was broken. When physicists tried to calculate the energy of a single electron, the equations returned infinity. The theory predicted that every atom in the universe should have infinite mass and infinite charge, a prediction clearly contradicted by the fact that we exist. Feynman's solution was a radical reimagining of motion itself, known as the path integral formulation, or the sum over histories. Classical physics tells us that if you throw a baseball, it follows one specific, predictable trajectory determined by gravity and drag. Feynman proposed that quantum particles work entirely differently. An electron traveling from point A to point B does not follow a single path. It follows every possible path simultaneously. It travels in a straight line. It loops in circles. It zips to the edge of the galaxy and back. It travels backward in time. It explores every inch of the universe before arriving at its destination. This sounds like mystical nonsense, but in the quantum realm, this superposition of histories is literal reality. To find the probability of the electron arriving, you must add up the contributions of all these infinite paths. And this is where the speed of light emerges from the shadows. Each path contributes a probability amplitude, a complex number with a phase. Think of these phases like the hands of a clock, spinning as the particle moves. For paths that respect the laws of physics, the clocks spin in sync. They add together constructively, reinforcing the probability. But for paths that are wild, paths that zigzag frantically or attempt to travel faster than light, the phases spin out of control. When a particle attempts a trajectory faster than light, the mathematics of the action becomes imaginary. The phase oscillates with infinite rapidity. One path points up, the next points down, the next left, the next right. When you sum these billions of superluminal paths, they interfere destructively. They cancel each other out with absolute precision. The contribution of faster-than-light motion to the final reality is exactly zero. This was Feynman's revelation. The speed of light is not a policeman stopping you from speeding. It is a filter. The universe allows every possibility to exist in the quantum sum, but it mathematically annihilates any history that violates causality. The barrier is not a wall. It is a silence. Faster-than-light paths do not contribute to the universe we observe because they interfere themselves out of existence. Feynman codified this behavior in his famous diagrams, deceptively simple doodles of lines and squiggles that represent the deepest interactions of matter. In these diagrams, we see virtual particles. These ghostly entities can, for brief moments, borrow energy and momentum that shouldn't exist. That they can appear to travel faster than light within the internal logic of a calculation. But they are not real. They are accounting mechanisms of the quantum field. When the final bill comes due, when two real particles interact, the superluminal debts are always canceled. Information never travels faster than causality permits. Yet the human mind rebels against limits. If we cannot accelerate to light speed, perhaps we can cheat. Science fiction and theoretical physics have long flirted with loopholes, tachyons, warp drives, and wormholes. But when we subject these concepts to the rigorous scrutiny of Feynman's quantum universe, they transform from dreams into nightmares. Consider the tachyon. This hypothetical particle would live on the other side of the barrier, traveling permanently faster than light, and it would require infinite energy to slow down to light speed. It sounds elegant, a mirror universe of speed. But in relativity, faster than light travel is mathematically equivalent to backward time travel. If tachyons existed, you could send a message to your past self. You could trigger a detonator before the signal was sent. This creates a causal loop, a logical paradox that unravels the consistency of physical law. A universe with tachyons is a universe where effects precede causes, where history can be rewritten before it happens. Feynman's path integrals suggest that such particles cannot exist because they would destabilize the vacuum itself. We see no tachyons, not because we haven't looked, but because the universe protects its own timeline. Then there is the Alcubierre warp drive. Proposed in 1994, this concept suggests contracting space in front of a ship and expanding it behind, riding a wave of distorted spacetime like a surfer. The ship sits in a bubble of flat space, never locally exceeding light speed, yet crossing cosmic distances in moments. It seems to bypass Einstein's rules, but the cost is catastrophic. To build such a bubble requires negative energy, exotic matter that exerts gravitational repulsion. Not only does this matter likely not exist in sufficient quantities, but the quantum consequences are horrifying. As the warp bubble plows through space, it would sweep up high-energy particles and radiation, trapping them in the forward wall of the distortion. When the ship arrives at its destination and the bubble collapses, this accumulated energy would be released in a focused blast of gamma radiation. You wouldn't just arrive, you would sterilize the destination planet, incinerating any life you came to visit. Furthermore, the interior of the bubble is causally disconnected from the walls. You cannot steer, you cannot stop, and you cannot turn it off. The warp drive is not a vessel, it is a tomb. Quantum tunneling offers another false hope. In this phenomenon, a particle appears on the other side of a barrier it shouldn't be able to cross. Experiments have shown that the peak of a wave packet can seem to cross a barrier faster than light. But this is a mirage. The information, the actual signal, is carried by the leading edge of the wave, which never exceeds light speed. It is like a shadow stretching across the ground. The shadow can move faster than light, but the object casting it cannot. While quantum mechanics allows for spooky correlations, like entanglement, where distant particles share a fate. But it strictly forbids the transmission of information. You cannot use entanglement to send a warning faster than light. The no communication theorem is a mathematical proof that quantum mechanics, despite its weirdness, respects the speed limit of causality. Every loophole closes upon inspection. Every trick to beat the house fails. Wormholes require the same impossible negative energy as warp drives, and would likely collapse into singularities the moment a single photon entered them. The universe is not merely making it difficult to cross this boundary. It is demonstrating that the boundary is a fundamental feature of existence. Feynman's legacy teaches us that the speed of light is woven into the quantum probability of every event. It is the reason atoms are stable. It is the reason forces behave as they do. The fine structure constant, a number determining the strength of electromagnetic interactions, is intimately tied to the speed of light. If the speed of light were infinite, matter as we know it could not exist. There would be no structure, no chemistry, no life. We are left with a chilling realization. The barrier is not external to us. It is internal. It is in the electron shells of our atoms and the firing of our neurons. We are made of quantum fields that propagate at this specific speed. To ask, why can't we go faster, is to misunderstand what we are. We are patterns of information updating at the cosmic frame rate. You cannot run faster than the speed at which your own existence is being rendered. Feynman showed us the mechanism of the limit, the cancellation of impossible paths. Einstein showed us the geometry, the curvature of space-time. Together, they reveal that the speed of light is not about travel. It is about the structure of the now. It defines the size of the present moment. But if this speed is the limit of causality, what does that mean for the universe at large? It means we are trapped in a shrinking bubble of reality, isolated from the vast majority of creation. The speed of light dictates what is real, what is past, and what is forever beyond our reach. To understand the final existential weight of this limit, we must look at the cosmic scale, where the speed of light becomes the speed of loneliness. The speed of light has nothing to do with light. This statement sounds paradoxical, yet it is the ultimate truth physics has uncovered. Photons travel at this velocity simply because they are massless, mere ripples in the electromagnetic field. They are not special. They are simply unburdened. If you stripped the mass from a bowling ball, it would instantly accelerate to 670 million miles per hour. If gravity has a particle, the graviton, it travels at this speed. When black holes collided in the LIGO detection of 2015, the gravitational waves arrived at Earth at the exact same moment light would have. The cosmic speed limit existed long before the first star ignited to illuminate the void. Its proper name is not the speed of light. It is the speed of causality. Causality is the logical architecture of the universe. It is the rule that insists the cause must precede the effect. If a rock strikes a window, the window shatters. The striking is the cause. The shattering is the effect. For this sequence to make sense, information about the rock's impact must travel from the point of contact to the edges of the glass. That information cannot travel infinitely fast. If it did, the window would shatter at the exact instant of contact, or perhaps even before, rendering the concept of sequence meaningless. The speed of light is the maximum speed at which 2 points in the universe can talk to each other. It is the refresh rate of reality. It is the tempo at which the cosmos processes the logic of existence. To understand the existential weight of this limit, we must look at the geometry it imposes on our lives. Well, you exist at the apex of a structure physicists call a light cone. Extending upward from your present moment is your future light cone, the volume of space and time you can theoretically influence. Extending downward is your past light cone, the volume of events that could have influenced you. Everything else, the vast, overwhelming majority of the universe, lies in the absolute elsewhere. These are regions of space-time that are mathematically severed from your now. Events happening there cannot affect you, and you cannot affect them. If the sun were to vanish this instant, we would not know for 8 minutes. For those 8 minutes, the sun would be a ghost, physically gone but causally present, holding Earth in orbit and bathing us in warmth. We live in a delay. We never see the universe as it is. We see it as it was. Well, we are trapped in a bubble of antiquated news, forever chasing a present moment that has already fled into the past. This isolation is not merely a delay. It is a prison sentence. The observable universe is approximately 93 billion light-years in diameter. This number seems vast, but it is a cage. Beyond this horizon lie galaxies we will never see, stars whose light will never reach us, and civilizations that are forever cut off from our knowledge. But the situation is worse. Because the universe is expanding, and that expansion is accelerating due to dark energy, the trap is tightening. Distant galaxies are being pushed away from us faster than the speed of light. This does not violate relativity because the galaxies are not moving through space. Space itself is expanding between us. The distance is growing so fast that the light emitted by these galaxies today will never bridge the gap. They are falling off the edge of the world. Every second, thousands of stars cross the cosmic horizon, vanishing from our causal future forever. We are living in the era of the last light. In the deep future, roughly 100 billion years from now, every galaxy outside our local group will have disappeared behind this veil. Future astronomers will look up at a sky that is empty, save for a few local stars. They will conclude they are alone in a static, eternal void, with no evidence of the Big Bang, no evidence of expansion, and no evidence of the trillions of other worlds that once shone in the dark. The speed of light, combined with expansion, is slowly erasing history. The ultimate expression of this causal tyranny is the black hole. Here, mass warps space-time so violently that the escape velocity exceeds the speed of light. The event horizon is not a physical surface. It is a silence. It is the point where the future curves inward. Once you cross this line, all paths forward lead to the singularity. You cannot escape because outside is no longer a direction in space. It is a moment in the past. To leave a black hole would require traveling backward in time. The speed of light ensures that the secrets held within these gravitational tombs are kept forever. It protects the universe from the paradoxes that might lurk at the singularity, hiding the breakdown of physics behind a veil of absolute darkness. Yet we must ask the terrifying question, what if the limit didn't exist? What if the speed of causality were infinite? At first glance, this sounds like freedom. Instant communication, instant travel, a universe without borders. But in reality, it would be the end of existence. If the speed of light were infinite, the sun would burn through its fuel in a microsecond. Chemical reactions would occur instantaneously. There would be no delay, no unfolding, no time for complexity to emerge. The universe would happen all at once, a blinding flash of everything occurring simultaneously, followed by eternal entropy. The speed of light acts as a cosmic damper. It forces interactions to happen sequentially. It allows the universe to digest itself slowly. It prevents the heat death of the cosmos from happening at the moment of creation. It gives us the most precious resource we possess, time. We exist because of the barrier. The delay allows structure. It allows the neural impulses in your brain to organize into thoughts rather than a chaotic discharge. It allows gravity to pull gas into stars before those stars explode. It allows the intricate dance of cause and effect that constitutes a life. Richard Feynman's path integrals showed us that the universe filters out the impossible, leaving only the causal. Einstein showed us that this causality is the bedrock of space-time. The speed of light is not a number. It is the structural integrity of reality. It is the wall that keeps the past from crashing into the future. It is the rule that prevents the universe from being a chaotic, a causal nightmare where effects precede causes and logic dissolves into madness. We are lonely, yes. We are isolated in our light cones, separated from the vastness of the cosmos by distances we can never cross. We are trapped in a single moment, unable to see the future or change the past. But this trap is our home. The walls of our prison are the very foundations of our existence. So the next time you look up at the stars, do not see them as distant lights. See them as echoes of a past you can never touch. Feel the delay in your own skin. Feel the 670 million miles per hour limit governing the firing of your neurons, the beat of your heart, and the flow of time itself. You are a creature of the delay, a child of the limit. And in that limit, in that finite, fragile speed, lies the only reason you are here to ask the question at all. The speed of light is not just a speed limit. It is the heartbeat of the universe, and it is beating for you.